Huwag ka maingay, mag-report ako. Okay. Good morning, students. So now we're going to discuss the module 5 of Principles of Geology, which is GEOHAZARDS. Okay, next. Okay. So when it comes to dynamism, there is nothing more ever changing than the Earth. Earthquakes rip along plate boundaries. Volcanoes spew fountains of molten lava, mountain ranges and seabed constantly being created and destroyed, and even tsunamis wiping up an entire city. Earth's scientists have long been concerned with deciphering the history and predicting the future of this ardent planet. Over the past decades, experts have made great strides in understanding Earth's inner workings. But this vigorousness changes the game arena. As the human empire continues to ascend, the place we call home strives to be ever dynamic and it produces new sprouts of life, yet taking down some. In this unit, we will tackle the different geohazards we experience and how they have shaped the entire civilization through their ravaging nature. Next. Okay, so geohazards. So, what comes to your mind when you hear about geohazards? Okay, so usually, masiseparate mo yung words into two. So we have geo and hazard. Okay, so hazard, as we all know, hazard is any potential harm or danger. So it is anything. It is an event may cause harm or potential na pwede kang mapahamak. Okay? So, connecting the prefix geo, meaning earth, so it is hazard wherein caused dito sa earth, dito sa kung asan tayo nakatira. Okay? Okay. Volcanism tayo. Next. Okay. Volcanism. So, of course, hindi na bago sa atin yung word na volcanism since nasa Philippines tayo, which is we here dwells a lot of volcanoes. Hindi na bago sa atin yan. So, volcanism is a term used to describe all geological phenomena correlated with the flow and transportation of igneous material from the planet's interior towards the natural terrestrial surface. Okay? Okay, so volcano, this is a hill, mountain, or fissure from which molten or hot rocks with gaseous materials are ejected. So, base dito sa definition ng volcano, so hill, mountain, or fissure, wherein nagre-release or nag-e-eject ng igneous materials, okay? So, not necessarily na kailangan ng hill or mountain, basta it is any opening sa crust natin wherein yung mga things sa baba, which is yung igneous materials, are ejected palabas up to the surface, okay? So, remember that. Okay, let's proceed to the parts of a volcano. Okay, so sa parts of the volcano, the first one is pipe. Okay, so pipe is the passageway in a volcano. It is also called conduit. So, yung pipe, it is a part of a volcano, yung straight line from the magma chamber, or mamaya discuss natin yon, yung source ng magma, it is the passageway of the magma. Okay, basically, dun dumadaan yung magma, okay? Okay, number 2, fissures. These are long, narrow cracks in the crust through which molten materials are ejected. So, fissures, any opening or cracks sa crust wherein molten materials are ejected. So, actually, fissures can be a volcano, as what I've said earlier, di ba? Volcano can be any opening sa Earth's crust natin wherein nag-e-eject ng igneous materials. So fissures can also be a volcano, but sometimes sa volcano we have it can be just a part of a volcano. So fissures can be a part of a volcano, but it can be also a volcano itself. Okay. So next, we have vent. Okay, pagsabihin natin yung venting crater. Okay? So vent, this is an opening in a volcano, while crater is the bowl-shaped depression in a volcano. So what's the difference between the two? Diba? Kasi usually kasi napagpapalit siya or misunderstood kasi ba vent is the opening and then yung crater, yung nakikita natin, di ba? Pag pupunta tayo sa bungangan ng bulkan, di ba? So basically, vent, vent is below the crater. Okay? So, crater is above the vent. Okay. So, paliwanag natin bakit. Okay. So, dito sa crater, so, ito yung part ng volcano wherein merong depression. Pag sinabi kasi natin depression, di ba, paglubog, okay? So, yung depression na yun, yung bowl shape, okay? So, that's the crater. So, vent is, is a tube or a passage naman papunta sa crater, okay? So that's the difference of the two. So hindi lahat ng volcano ay mayroong crater. Like sinabi ko kanina, yung fissures, wala namang crater ang fissure na volcano, di ba? Kasi opening lang yun, okay? So vent is an opening of the volcano, okay? So ayan. Okay, so when we say vent, it is ito yung sinasabing bunganga ng bulkan, okay? And then the crater, ito yung mamaya di-discuss natin yan kapag na-discuss natin yung caldera mamaya, okay? So next, fumaroles tayo. Fumaroles, these are secondary vents that emit only gases. So kanina diniscuss natin na yung vent, okay, ay opening sa volcano. Okay? So dito naman sa fumaroles, wait, teka lang. Okay, nag-check lang ako ng sinaing, okay? Hindi pa ako nababother din sa sinaing na susunod na. Okay, so nasa na ba tayo? So we have here fumaroles, okay? These are secondary vents that emit only gases. Okay. Next, magma chamber. Okay, so when we think about chamber, okay? Di ba, pag sabi natin chamber, we think about a storage, an area, a room, di ba? Chamber. Parang sisidlan, ganun, chamber, okay? So, connecting it to magma, okay? So, this is the magma reservoir and is a geologically weak structure. Okay. So, basically, yun yung, kung nasan yung magma, okay? Andun yung pinaka-parang storage room, yung reservoir, okay? Next. Number 7 tayo, caldera. Okay. Okay, dito naman, we're going to differentiate naman the crater and caldera kasi ito rin usually napagbabaliktad siya, okay? Okay, so crater and caldera are both vent tops. Sabihin, both pareho silang nasa ibabaw ng vent. So ano man pinagkaiba nila? So when we talk about crater, it's more general. Its meaning is more general kasi, di ba, we have, of course, volcanic crater, and we also have meteorite crater. Basta any depression sa land, we call it crater. Okay. So that's a more general meaning. But here, sa volcanism, it is caused by an outward force. Okay, so during an eruption. So from nagsimula siya sa isang eruption, okay, wherein yung vent, yung opening ng volcano is damaged, okay? So because of that eruption, uh, yung yung force na na yung force na nai-release doon sa vent ng volcano, and then that will cause an outward force forming that bowl shape, okay, na crater, okay? And ano naman ang caldera? So sabi dito sa caldera, this is a very large basin-shaped crater at the top of a volcano formed after an intense eruption or series of eruptions. So ano nga bang pinagkaiba niya, Kuya Balatik, sa crater? So once na, ganito kasi ang concept niyan, once na nagkaroon ng intense eruption or series of eruption, may tendency na yung sa magma chamber magkaroon ng partial emptying or yung na squished out, okay? Nagkaroon ng squishing out ng nilalaman ng magma chamber. And then, gaya nga ng definition natin kanina, magma chamber is a geologically weak structure, okay? Geologically weak structure kung babalikan natin. Okay, so that is geologically weak structure. So since na-empty yung space niya, okay, I mean na-empty yung nilalaman niya, so the tendency magiging unstable yon, or hindi niya ma-maintain yung structure niya, sarili niya, dahil nga geologically weak siya. Okay, so ang tendency nun, magkakaroon ng inward collapse, okay, sa magma chamber, okay? And then dahil doon, maapektuhan rin yung nasa taas. So dahil magkakaroon ng collapse, pag sabi natin collapse, pagguho, okay? Inward na pagguho. So dahil doon lumalaki. Doon lumalaki yung crater natin, forming a caldera, okay? So caldera is a crater, yet there happened na something sa magma chamber, okay, that caused that yung paglaki sa espasyo. So minsan sinasabi nila na crater daw ay mas maliit sa caldera, and caldera yung mas malaki. So actually, hindi naman siya nagmamatter sa size. So it actually genesis, kung saan siya nagmula, kung paano siya na-form, yung mismong ano na yon. Pero basically, usually kasi, kapag sinabi natin caldera, mas malaki talaga siya sa crater. So, another trivia lang, nasa Philippines ang largest caldera, which is yung Apolaki caldera, which is a diameter of 150 kilometers and sounds bandang east ng Isabela, doon siya nakikita. Okay? So be proud na sa atin yung largest caldera sa buong mundo. Okay? Okay, next. Okay, next. Classifications of volcano. So we can classify volcano according to a lot of aspects o factors or ganon. So here, una muna, i-classify natin yung volcano according to its shape. So we have three. One is shield volcano, two cinder cone volcano, and then three composite volcano. So when we okay, basa natin yung sa shield volcano. Sabi dito, this type of volcano is characterized by a broad base and a shallow slope formed by less viscous lava. Okay, discuss natin yung ano yung viscous lava. So when we say viscous or sabating viscosity is a measure of resistance of a fluid to flow. Okay, resistance. Okay, yung parang pagpigil. Okay, yung measure ng parang pagpigil ng flow ng isang fluid. Okay, so when we say a fluid is highly viscous, so when we say a fluid is highly viscous, means it is sluggish, mabagal. Sabihin, mataas yung resistance ng pag-flow niya. When you say less viscous, mabilis. Diba? Okay, so going back, so dito sa shield volcano, it is formed by less viscous lava. Ibig sabihin, mabilis yung flow niya. So dito sa shield volcano, it started na kung saan when it ejected molten material, di ba? Nag-eject siya ng lava, okay? Dahil nga less viscous siya, mabilis siyang mag-travel, di ba? Mabilis siyang mag-travel, mabilis siyang mag-flow. And dahil doon, pahaba yung nagiging shape ng volcano natin. And then nagko-compile, ang itsura niya pahaba. Pwedeng paki-next saglit muna. Okay, so yung itsura niyan, dito sa pangatlo, sa shield volcano, yung flow niya, basta pahaba siya, okay? Okay. When we say shield volcano, mukha sang shield, kaya siya tinawag na shield. Okay? So, sa shape niya mukha sang shield and pahaba. So, mababa yung slope niya. Okay, next. Cinder cone volcano naman. So, this type is also known as a scoria cone and is formed from pyroclastic fragments that give rise to the volcano's bowl-shaped crater. So, its lava is characterized by a darker appearance and is mafic in nature. Okay, so dito sa cinder cone volcano, so mafic, when we say mafic in nature, so pag sabi natin mafic, para siyang igneous or silicate material na rich in magnesium and iron, and kaya nga sabi dyan, darker siya. Okay, so when we say cinder cone volcano, cinder, okay, cinder are parang fragments. Fragments siya. And then, it is formed, dun sa cinder nga, dahil nung nagkaroon ng eruption, and then, nagkaroon ng fragmentation nung materials, or fragmentation yung parang broken down into smaller pieces, ganun. Okay? So, napupunta siya sa sides nung volcano, or kumbaga sa bunganga, sa lips ng volcano. Okay? So, dahil doon sa formation na yon, doon na-form yung cinder volcano, which is dahil nga sa side siya na-form. So, that gives rise to the yung bowl shape being ng crater. Okay? Next, composite volcano. Okay, sa composite volcano naman, this type is also known as stratovolcano, from strato meaning high. Okay, so this volcano is characterized by a steep slope and a composition of a mix between lava and cinders. So, kung mapansin natin, yung sa structures nila, parang sa shield, mababa yung niya, yung height niya, then cinder, medyo katama lang, and then composite, ito yung mataas, and then maano yung slope. Okay, parang ganoon yung concept natin dito sa classification of volcano based on their shape. So dito sa composite volcano, from the word strato, doon nga sa stratovolcano, tinatawag siyang stratovolcano. Strato meaning high. Okay, so pag sabi natin steep, matarik yung slope niya. So mataas siya, and then matarik yung slope niya. So that's composite volcano. Next. Ayan. So may back. Ayan. So may kita natin yung itsura nila. Ayan, so composite volcano, cinder volcano. Ayan. And then sa shield volcano. Okay, next. Okay. Factors that affect the shape of volcanoes. So we have 5 here. So 1, lava's viscosity. 2, shape of the vent. 3, frequency of eruptions. 4, intensity of eruptions. And then 5, type ng fissure. Next. Okay, let's now discuss magma versus lava. Let's differentiate. So magma is the molten material found beneath the Earth's surface, while lava is the magma that reaches the Earth's surface. So basically, magma is yung nasa loob, and lava yung nasa labas pag nilabas na. Okay? So magma yung molten material sa ilalim, and then lava, when it reaches the Earth's surface, then it is now called lava. So ganun lang siya. Yun na yung concept niya. Okay, next. Okay, types of magma. Okay? Okay. Different types of magma. So we have here three. So the first one is basaltic magma. So the other name is mafic, yung explain natin kanina. And then, location of formation sa divergent plate boundary. Divergent means maghihiwalay, okay? Then, silica content least, okay? Pinakamababa. Then, the tendency to form lava is the highest. Then, the tendency to form pyroclastic is least. So, idagdag ko lang, when we say, di ba, silica content, pag sinabi natin silica content dito sa lava, okay? Di ba, sinabi natin na yung kanina, yung sa shield volcano is mafic in nature, okay? So, sabihin nun, less viscous. So, may connection yun sa silica content niya. Pag mataas kasing silica content niya, mataas rin yung viscosity niya. Ibig sabihin, pag mas mataas yung silicate niya, so, mas mataas yung resistance niya, mas resistant siya sa pag-flow yung fluid na yun, or ito nga, sa lava na to. Okay? So, dito, sa basaltic magma, so, mababa yung silica content niya. I mean, 50%, and it is the least. It is a type of magma that has the least silica content. Okay? Next, andesitic magma. Okay? Other name, intermediate. Okay? Location of formation, convergent plate boundary, silica content, intermediate. Okay, 60%. The tendency to form lava is intermediate, and the tendency to form pyroclastic is intermediate. Next. Okay. Next is okay, pyritic magma. Okay. It is also called felsic magma. Its location is of its formation is sa continental crust. Silica content 70%, and it is the highest among the three. It has the highest silica content. Okay, the tendency to form lava is least. The tendency to form pyroclastic is highest. Next. Okay, let's proceed naman sa types of eruptions. So, the following are the types of eruptions according sa PHIVOLCS, or the Philippine Institute of Volcanology and Seismology. So, we have here 6. Okay, so the first one is phreatic eruption. So, this is phreatic eruption is a steam-driven eruption. Hence, it is also called hydrothermal eruption. So, this eruption involves water, steam, and ash with other rock fragments derived from pre-existing rocks without the ejection of fresh magmatic materials. So when we say phreatic, pura lang siya tubig, steam, pero walang involvement ng magmatic materials, okay? So once nagkaroon ng gantong uri ng eruption, yung isang volcano, so ano lang siya, steam, water. So yung mga gantong uri ng volcano ay ang crater nila ay, or crater or caldera nila is with lake. Okay? Kasi, of course, kung may steam, kung may ganyan, of course, may involvement ng water. Okay? So, when we say phreatic eruption, may water na involved. So, may lake, gaya nung sa ibang mga volcano, gano'n. Okay, next, Tupilayan eruption. Next, this is an eruption is characterized by a gas-rich pasty lava that accumulates to form a dome. Okay? So dito sa eruption na to, once it released its material, so nagfo-form siya ng dome. So pasty kasi yung lava niya. So dahil doon, nag-accumulate siya, forming a dome. Okay. Next, 3, phreatomagmatic eruption. So this eruption is characterized by violent eruptions due to contact between water and magma sa ilalim. Okay. So recently, Taal volcano erupted, right? Last January 2020. So Taal volcano's eruption last January 2020 is a type of phreatomagmatic eruption according to PHIVOX. Okay? So sabihin nun, nagkaroon ng contact si water, di ba? Sa Taal, may caldera lake tayo, di ba? Sa Taal, Taal Caldera Lake. Okay? So dinarayo pa nga ng maraming turista yon. Okay? So doon, nagkaroon ng contact si water at si magma sa ilalim. That's why nagkaroon ito ng violent eruption na kung saan yung smoke pa nga kumalat una northern and then kumalat rin hanggang sa Visayas, di ba? So, ganun yung sa phreatomagmatic eruption. Next. Next. Okay. Next, number 4, volcanic eruption. So this is a short, violent, relatively small explosion of viscous magma that results from the fragmentation and explosion of a plug of lava in a volcanic conduit or from the rupture of a lava dome. So volcanic eruption, short explosion of viscous magma, yet yet violent siya, okay? So that's volcanic eruption. So it could travel upwards once na nag-release siya 350 meters per second. Imagine how fast that explosion is, di ba? So yet ano lang siya, short lang siya, yet violent. Okay. Next, strombolian eruption. Okay, this is a distinct burst of fluid lava from the mouth of a magma-filled summit conduit. So the explosions of can reach of large distinct na event na strombolian eruption, large bubble gas, which travel upward in the magma-filled conduit until they reach the open air. Next, Plinian eruption. Okay, this type of volcanic eruption is the largest and the most violent. So it is caused by the fragmentation of gassy magma and is usually associated with very viscous magmas. Okay, so sa Plinian eruption, sabi ito daw yung pinaka-largest, most violent. Okay, so sabi pa nga dito, it could cause an explosion kung saan yung pag-release ng materials could reach a speed of 50 hundreds of meters per second, and it can reach up to 50 kilometers high. Right? Imagine that's 50 kilometers yung taas niya. So ganun yung Plinian eruption. That's how violent Plinian eruption is. Next, tingnan natin yung itsura nila. Yan. So we have here, ayan, Plinian volcano. Yan. So we have here Vulcanian. Wait, stop muna.
Stop muna nga.
Wait, parang malulubat na ako. Parang humihina, no? Asang banda? Kayo pa ba? Yung humihina?
Kanina kasi akala ko sa akin lang. Kasi nung nagtanong nga ako kay Kuya Charles, tapos may mga parts na medyo mahina talaga. So kailangan nila mag-install ng volume booster.
Mahina talaga.
Merong parts, yes.
Saan parts? Uy, ayos lang mo. Parang hindi ko na-explain ng maayos yung sa bandang ano. Bigla akong nawala, parang hindi ko naaral yung sa ano, saan ba yun? Sa crater at saka sa vent. Hindi ko na parang maayos yung ano, yung dalawa.
Maayos lang naman yung ano
Ayos lang.
Hmm.
Pero hindi ko satisfied dun sa explanation ko.
Sika lang.
Bakit parang malulubat ako? Ganun to pag maano eh.
Kasi talaga akala ko kanina, ayaw ko mag-chat kasi akala ko sa akin lang. Mahina. Hindi lang sa tabi niya. Kundi lang ako nakapunta sa GC. I-diagram daw eh. Check mo nga sa next slide, kuya. Shutdown. Kuya, dali check mo nga kung merong diagram sa kabila.
Hello? Okay, narinig ako.
Narinig ko yan.
Okay, tanginom lang ako. Sakta na lang muna ako. 3-3 pagsasalita mo eh. Tsaka yung sinain ko pala. Bakit? I'm back. Isa ilang daw si Kuya Daliray. Kami tagbabantay din ako ng sinaing dito. Saan? Ano yun? Ano yun? Oh, awit. No, no, no joining here. Bawal, bawal. Bawal ka muna dito. Bawal kung may itong bata ka. Uy, huwag ka sumingit dito, bata ka. No, no. No, I said no. Baba ka muna. Later na, later na. Later na po. Ayun. Huwag na po. Di pa po pwede. O, sige na, pumasok ka na. Sinagay mo dito. Baka yung ako ito. Uy. Sabi ko na sa'yo eh, huwag ka dito eh. Akong ganun disturbo dito eh. Puta ka? Disturbo dito. Anong gulo-gulo dito ha? Ay, nakukulit. Hello. Okay na? Nasakit na lang mo kakadada ako dito. Nasaan na yung slide? Ito pala. Sabi ko nga, ito na yung slide. Saan ba ako natapos? Dito na ba? Types of eruption?
Kuya. Restart na lang dyan yung sa part mo yan.
Ng picture? Ito?
Kasi di ba may
I-discuss
part
ko ba
doon
kayo?
sabi mo kanina, i-discuss mo eh.
I-discuss ko ba?
Hindi mo pa din-discuss.
Okay.
Kanina. Oo.
Pero natapos ko yung lahat ng types ng eruption. Hanggang
tapos
ano?
ka na doon.
Okay.
Tapos, pumunta ka, sabi mo, tingnan natin yung diagram sa next slide, sabi mo.
Okay. Sige.
Mas naintindihan.
Dinig yung background noise?
Hindi man.
Hindi naman yung nagluluto, hindi man rin. Okay. Okay, so tingnan natin dito yung itsura ng mga eruptions dito sa picture na to. Okay? So we have here Plinian eruption, yung makapansin niyo yung pinakamataas, yan, yung parang mushroom, yung ganyan yung itsura niya. So that's Plinian eruption, ganyan siya kataas. Okay? So we have here katabi nito sa upper right ng Plinian eruption, yung volcanic eruption, ayan. Then we have here sa baba, Pelean eruption. So, yung makikita nyo, may parang dome. Yan yung sinasabi natin na na-form na dome dahil din sa past na lava na nare-release during Pelean eruption. So, we have here also Strombolian eruption. And then, ito, may bagong dalawang sulit. Hindi natin siya kasama. Okay? So, next. Types of eruption. Next slide, please. Okay, so types of eruption. So, we have here naman, kung kanina, yung types of eruption sa PHIVOX, ito naman, sa ano naman natin, sa location naman nila. Babali naman natin sa location. So, we have here 3, crater eruption, fissure eruption, and flank eruption. So when we say crater eruption, this is the eruption from vertical pipe-like chambers. Okay, so crater eruption yung usually na yung may cone, okay? That's crater eruption. That's crater eruption na form doon. Okay? So sa fissure eruption naman, this is the eruption from a plate-like vertical dike, okay? So fissure eruption, ilang beses natin nabanggit kanina, fissure is any opening sa Earth's crust, okay? And then flank eruption naman, this is the eruption from the sides of a volcano, parang secondary sa flanks, yung tinatawag na flanks. Yung nagaganap yung eruption na yun, okay? So that's the volcanic eruptions based on their locations. Okay, next slide. Okay, next. Let's now proceed sa eruptive styles. So we have 2. So mali na siya tandaan dahil, of course, opposite sila, dahil dalawa lang sila. So the first one is effusive eruption. So this is also called oozing eruption or quiet eruption. So from the word itself, quiet. So it means it involves the emission of fluid lava flows and is characterized by lava lakes near the volcano's vents. So quiet eruption from the word itself, diba? Peaceful. I mean not peaceful, wala namang peaceful na eruption, but compared to other types of eruption, masasabi natin talaga quiet na siya. Okay? Then next naman, sa explosive naman, taliwas naman sa effusive eruption, this eruption involves the emission of ash clouds and pyroclastic flows. Okay? So rock, ash, pyroclastic materials are the common ejected materials along with pretty viscous lava. Okay? Next. Volcanic materials. Okay? So, first, we have here AA lava. Okay? So, this lava is also called black lava. So, it is characterized by sluggish motion and it has sharp jagged surface. So, sluggish motion. So, mataas ang viscosity, mataas ang silica content. So, that's AA lava. And when it cools, pag lumamig siya or pag nag-harden na siya, So it forms a sharp and jagged surface. Okay? Next naman. Next naman is how we pronounce this, di ba? We pronounce it as pahowi-howi lava. Okay? So, pahowi-howi lava is a type of lava that is hotter, thinner, and less viscous lava compared to DAA lava. So, after cooling, its surface appear flexible and have ropey, smooth, wrinkly lava flow. So, itong pahowi-howi na to, actually, galing siya sa Hawaiian word na howi. Okay? So, howi connected siya sa pagsasagwan, 'di ba? Pag nagsagwan ka, yung surface ng water once na nagsagwan ka, parang ganyan yung itsura niya kasi. So, dan nakuha yung pahowi-howi lava. Okay? Kasi parang ganyan yung itsura niya. Next. Wait time first, may problem ulit. Let's proceed to pillow lava, okay? So, pillow lava, as said, is the type of lava that oozes gently from the ocean floor. So, usually, yung ganitong type of lava is underneath volcano na uh, nasa ilalim ng dagat, okay? So, kaya siya na-form na ganyan yung itsura niya para siyang pillow kasi once na nagkaroon ng eruption, yung lava, mabilis siyang magsosolidify dahil nga nasa ilalim siya ng tubig, and because of that, ganyan yung naging itsura niya, and mabilis siyang nagsosolidify, pero sometimes merong lava pa siya sa loob. Ganyan yung characteristic ng pillow lava. Okay? So let's move on. Next, please. Okay, pyroclastic materials. So, pyroclastic materials are hot, fast-moving ash, gas, and rock. So, ito yung mga inilalabas ng volcano. So, yung tinatawag natin pyroclastic materials. So, the first one is bomb. So, this is also called a block or ballistic. Its size is greater than 64 millimeters in diameter. So, itong bomb, ito yung mass ng lava na nagsosolidify sa air. Okay? So, sabi nga kanina, it is usually 64 millimeters. Okay? 64 millimeters greater, okay? So, kapag mas maliit siya, mas fragmented siya, okay? So, ang tawag na natin doon ay lapili, which is i-discuss natin mamaya. Okay? So, next po. Okay. So, first, we have Kaodang bomb. So, this is formed when ejected material is still molten when it hits the ground, forming a flattened pancake shape similar to Kaodang. So, usually, itong classification natin ng bomb is nakabase sa itsura niya. Kung anong itsura niya kapag nag-solidify na siya, yung itsura niya, okay? Pero minsan sa sa Genesis or yung pinagbulan, pero usually kasi kapag nagkaroon sila ng iisang pinagbulan, isa lang rin yung naging itsura nila. Katulad niyan, kapag yung volcanic material is still molten kapag nag-hit siya sa lupa, okay? So, ganyan naging itsura niya. So, isa lang din sila. Okay? Next. Okay, next. Ribbon bomb or cylindrical bomb. So, this is formed when highly to moderately fluid magma ejected as irregular strings and blobs The strings break up into small segments which fall to the ground intact and look like ribbons. Hence the name ribbon bomb. Hence the name ribbon bombs. This bomb that is circular or flattened in cross section is flattened along its length and has tabular vesicles. So that is ribbon bomb or cylindrical bomb. Next. Okay, next. Spherical bomb. So this is formed from the word itself naman, di ba? Spherical siya. Okay? So this is formed from high to moderately fluid magma. In the case of spherical bombs, surface tension plays a major role in pulling the ejecta into spheres. Okay? So that's how spherical bomb is formed. Okay? Kapag nagkaroon ng surface tension. Okay? So next. Okay, next. Bread crust bomb. Okay? So, wait. Okay, so bread crust bomb. This is formed if the outside of the lava bombs solidifies during their flights. Okay? During their flights. Sabihin, nasa ere pa lang siya, hindi pa siya bumabagsak sa Earth's surface. Okay? So it may develop crack outer surface as the interiors continue to expand. So dahil nga nasa ere pa lang siya, nagsosolidify na siya. So, di ba kapag mga hot materials, so tendency is nag-expand pa siya. Okay? So pagkabaksin niya sa lupa, nag-expand pa yung interior parts niya. So dahil doon, nagbe-break yung mismong bomb. Okay? Next. Okay, cord bomb. Okay? So these are bombs that have rinds of lava enclosing a core of previously consolidated lava. The core consists of accessory fragments of an earlier eruption, accidental fragments of country rock, or in rare cases, beads of lava formed earlier during the same eruption. So from the word itself, core. So meron siyang core na enclosed by yung sinasabi nating rings of lava. Okay, so that's cord bomb. Next. Okay, spindle bomb. It is also called fusiform or almond bomb. This bomb has an elongated form that tapers down at each end with a relatively smooth surface. Many have an almond shape. So this bomb is shaped by a whizzing trajectory through the air. So, kung mapapansin natin dito sa picture, dun sa shape niya, okay, so para siyang almond, yung itsura niya, okay? So that's how we classify spindle bomb. Okay, so now let's proceed to lapili, okay? So second ano natin. So as I have mentioned earlier, so lapili is mas maliliit siya kaysa sa bomb, okay? So kapag mas malaki siya ng 64 millimeters, mas malalaki siya, ibig sabihin, that's a bomb. So kapag mas maliliit na fragments, so yun yung tinatawag na natin lapili, okay? So lapili, sabi dito, it is also called volcanic dust or volcanic cinder. So its size ranges from around 2 millimeters to 64 millimeters. Okay? So the first one, okay, this is natin itong una. Okay. The first one na type ng lapili ay Pilis hair. Okay? So this lapili is made of multi-material, Pilis tears. Okay? So this lapili is made of molten material that becomes teardrop shape. Okay? So, tingnan niyo yung itsura. Okay? Para siyang patak ng luha, di ba? So, parang medyo parang spherical, ganun. Tapos parang medyo in-stretch lang ng konti na parang luha. So, ganun yung itsura niya. Parang siyang patak ng luha. Next. Okay, next. Phyllis hair. Okay, so this is a stringy multi-material. So, from the hold itself, mukha siyang buhok. Okay, para siyang strands of hair. Okay, so next. Okay, next. Sputter. Okay, so sabi dito, sputter is the fragment produced by effusive eruptions that remains airborne for only a short amount of time so that it's still liquid when it hit the ground surface. Okay? So from the word itself then, sputter parang patak-patak. Ganun yung itsura niya. Okay? So that's sputter. Okay. Then lastly, volcanic ash. So this lapilli has a size of less than 2 millimeters. So kung kanina, kapag bomb, 64 millimeters later. And then kapag lapilli naman, between 2 to 64. Okay? And then ito namang volcanic ash, abo, di ba? So mas maliliit siya sa 2 millimeters yung size niya. Next. Okay, next. Events during volcanism. Okay? So, una, extravasation. Okay? This is the outpouring of molten lava from a volcanic vent. So, usually natin nakikita kapag basta nagkaroon ng flow ng lava sa galing sa isang vent. Not necessarily na sa main vent, basta sa any opening sa volcano, basta nagkaroon ng flow, that's what we call extravasation. Okay, next. Okay, next. Tumescence. Okay, so tumescence is the doming of a volcano. Okay, for dahil sa definition, this is yung pagka-dome ng volcano, that is what we call tumescence. Okay, so number 3, outgassing. So this is the release of gas from the Earth's interior during an eruption. So pag-release ng gas, once na nagkaroon ng eruption, hindi lang flow ng lava, diba? Meron din release din ng gas from the Earth's interior dahil nga mainit doon. So nagre-release din ng gas simultaneously. Okay, next. Okay, next, tephra flow. Okay, so this is the flow of fragmental material produced by a volcanic eruption regardless of composition, fragment size, or replacement mechanism. So any any flow ng pyroclastic materials natin from the vent pababa, that's what we call tephra flow. Okay, next. Okay, lahar. Okay, so lahar is a violent type of mud flow or debris flow composed of a slurry, pyroclastic material, rocky debris, and water. The material flows down from a volcano, typically along a river valley. Okay, so ito usually kasi minsan tinatawag natin ito na lahar flow, but actually lahar is the event, not hindi yung mismong object. Lahar is an event. So hindi natin tinatawag doon na lahar flow kundi lahar. So this is the flow, okay? ito yung sinasabi ng violent mud flow ng slurry pyroclastic material. Flow din siya, but here, slurry. So, ibig sabihin, may present ng liquid, yung ano, gano'n, medyo liquid yung re-release niya, okay? So, sabi nito, slurry, it is composed of slurry, pyroclastic material, rocky debris, and water. So, that is lahar. Next. Okay, next, debris avalanche. Okay, so debris avalanche is a shallow landslide saturated with water that travels rapidly downslope as muddy slurry. So compared to lahar, it is much smaller. Okay, so medyo may pagkakapareho sila ni lahar at itong si debris avalanche, but compared to lahar, as sinabi dito, it is much smaller. Si lahar mas violent yung pag-flow niya. Okay? Next. Okay, Nui Ardente. Okay, so this is a turbulent, fast-moving cloud of hot gas and ash erupted from a volcano. So it forms during explosive eruptions as columns of erupted material collapse, or during non-explosive eruptions when volcanic rock collapses. Okay, so ito sa event na ito, gaya ng nasabi dito, may fast movement ng cloud of hot gas once na nagkaroon ng eruption. Okay, so kung makikita niyo sa picture, para siyang kumpol ng smoke, or basta hot gas siya, so mabilis yung flow niya. Okay, so that is it. Okay, next. Okay. Proceed naman tayo sa next. Okay, sabi dito, how can we tell when a volcano will erupt? So, paano nga natin malalaman kung yung isang volcano nga malapit ng sumabog or magkakaroon ng tanda ng pagsabog? Okay? So, una, there's an increase in the frequency and intensity of felt earthquake. So, may kita nila yun sa mga ginagamit nating instruments sa pagdedetect ng earthquake, okay? Sa mga sa seismograph natin, okay? So, may kita natin na yung napapadalas at malakas yung earthquake na nararamdaman malapit sa bulkan. Okay, so that's a sign. Okay. Next, noticeable steaming of or fumarolic activity and new or enlarged areas of hot ground. Okay? So, yun, kapag may steaming, sabihin, may release ng hot materials. Sabihin, may source ng mainit na yung volcanic material. So, that's a sign na a volcano will erupt. Okay? Number 3, subtle swelling of the ground surface. Okay? So, ito yung sabing pamamaga. Okay? Pamamaga sa, di ba kung isa naririnig nyo sa balita, diba? Parang pag malapit ng may pahiwatig yung bulkan, so namamaga yung surface, or mas umiinit yung mga hot spring, so ganun siya. Okay? Next, number 4, small changes in heat flow. Okay? Yung paggalaw ng ng heat natin. So may mga detectors tayo dun sa detectors natin kung paano natin na-monitor yung heat flow. So pag may nakitang change, small change sa heat flow using those instruments, so that could be a sign. Okay. Next, changes in the composition or relative abundances of fumarolic gases. Okay, so hindi lang release ng fumarolic gases, so medyo nagkakaroon din ng changes sa components or yung composition sa gases na nire-release ng volcano. Next, bulging or swelling of the volcano. Gaya na sabi kanina, pababaga, hindi lang sa ground, sa bunganga ng vulkan. Okay? Next, increase of temperature of the ground. Gaya na sabi kanina, and of the lake in the crater. Okay? Next. Okay, volcanic explosivity index. Okay, so volcanic explosivity index or VEI is a numeric scale that measures the relative explosivity of historic eruptions, the volume of products, eruption, cloud height, and qualitative observations using terms ranging from general to megacolossal are used to determine the explosivity value. So may kita natin dito kung paano natin kina-classify yung di ba, may classification dito yung mga iba't ibang uri ng eruption, di ba, na pinagdaanan natin kanina. So nakabase rin to sa kung ano yung volume na ine-eject na volcanic materials, then description kung gaano kalakas yung pag-erupt, then kung kataas yung pag-release, okay, ng volcanic materials, plume, okay, plume. This is the length or yung layo niya sa source, okay, so plume. Then frequency, kung gaano kadalas yung pag-erupt niya, okay, so that is VEI. Next. Okay. Next, Pacific Ring of Fire. Mostly naman sa atin siguro familiar na dito sa Pacific Ring of Fire since the Philippines is located along this ring. And sabi nga dito, okay, basahin natin. Pacific Ring of Fire or Circum-Pacific Belt is a path along the Pacific Ocean characterized by active volcanoes and frequent earthquakes. So its length is approximately 40,000 kilometers. It traces boundaries between several tectonic plates, including the Pacific, Juan de Fuca, Cocos, Indian, Australian, Nazca, North American, and of course, the Philippine plate. Okay? So 75% of Earth's volcanoes, more than 450 volcanoes, are located along the Ring of Fire. So hindi natin nagugulat sa dami ng volcanoes natin. That's because we are located along the Pacific Ring of Fire. So 90%, and also 90% of Earth's earthquakes occur along its path, including the planet's most violent and dramatic seismic events. Okay? So actually, araw-araw naman lumilindol sa Pilipinas. If you're going to look at FIVOC's Facebook page, so oras-oras nagre-report sila doon ng update sa iba't ibang parts ng Philippines. So kung mapansin nyo, madalas talaga sa isang araw hindi lang actually isa, napakaraming times. So ganyan kadalas yung earthquakes ito. But hindi natin nararamdaman dahil hindi naman siya feeble, hindi naman minsan hindi madalas, hindi malakas. Okay? pero madalas yes. Okay, next. Okay, now let's tackle about the extraterrestrial volcanism. So when we say extraterrestrial volcanism, this is the volcanism experienced outside the Earth's vicinity. So any volcanic activity or yung volcanism na nangyari sa labas ng Earth, so that's what we call extraterrestrial volcanism. So based upon observations from Earth and from space vehicles, only 4 bodies in the solar system have volcanic confirmed volcanic activity. So, ito lang yung mga babanggitin natin. Yung nagkakaroon ng merong volcanism sa vicinity nila. Okay, so unang-una, of course, yung Earth, and then yung Io, moon of Jupiter, next Triton, moon of Neptune, and Enceladus, a moon of Saturn. Next. Okay, next, cryovolcano. So this is a type of volcano that ejects volatiles such as water, ammonia, or methane instead of molten rock. So we have a prefix here. So cryo. So kung familiar kayo, nagagamit siya dito. So we have, kung meron tayong hydrosphere, lithosphere, atmosphere, geosphere, okay? So we also have cryosphere, which is dito sa Earth, this is the icy part or yung sa mga frozen parts ng Earth, yung mga North Pole, South Pole, like that, yung cryosphere natin. Ito naman yung type ng volcano kung saan imbis na molten rocks, imbis na hot lava and hot pyroclastic materials, instead, malalamig. Di ba sabi, ang nalalabas dito ay water, ammonia, or methane, which is malalamig, okay? Yun yung release niya instead na hot materials. So that's cryovolcano. Next. Okay, next, isopac maps. So these are contour maps that show the thickness of the volcanic ash deposits. So kung makikita nyo dito sa diagram natin, so we have here, dito starting ito, yung may active crater tayo dyan. And then mula dun sa active crater, red, and then naging orange, light orange, yellow, and then sa super light yellow na siya. So, of course, mula dun sa bunganga ng bulkan, so dun yung pinakamakapal. So, dito sa isopac maps, sabi nga dito natin pinapakita kung gaano kakapal yung volcanic ash na nare-release or nagsa-scatter. So, of course, mula dun sa bunganga ng bulkan, okay, so dun yung pinakamakapal. And then, habang pa rin na palayo, habang nag-disperse, okay, so that's when luminipis or luminipis yung ano natin, yung volcanic ash natin, of course. Okay, next. Okay, next, effects of volcanism. So, of course, we have two. Unahin natin yung positive effects. So, una, ang positive effects ng volcanism, geothermal energy production due to volcanism. So, geothermal energy, this is a type of energy na kung saan ginagamit natin yung heat ng Earth. So, geo means, yung sabi natin kanina, di ba? Meaning Earth. And then, thermal or thermos, di ba? Meaning parang heat, di ba? Geothermal, okay? So, ito yung heat na galing sa ito sa Earth. So, Sa next module, pag-aaralan natin yan further. But for now, we'll say that this is a positive effect dahil isa tong source of energy, of course. So marami itong nakapaganang mga mechanisms na ginagamit natin. Okay? So, number 2, rising magma brings it various valuable minerals. Okay? So, di ba, pag nagkakaroon tayo ng sa eruption, so, nagkakaroon tayo ng okay, di ba? Kasi nagkakaroon tayo ng formation ng minerals natin. Okay? So next, number 3. Okay, volcanic eruptions help scientists understand the Earth's internal processes while tourists get to enjoy. Of course, tourist spot ang mga volcanoes, okay, lalo na kapag may crater lake, I mean. So that will be helpful sa tourism natin, okay? And number 4, ash ejected by the eruption acts as a good fertilizer. Next. Okay, negative effects of volcanism. Okay, so una, deposit of pyroclastic flow can bury areas within river, valleys, and plains. So, of course, pinapalubog niya yung mga nearby areas natin sa volcano. Okay? Next, number 2, areas buried by lava flow will not be usable for a long time because lava solidifies into a massive rock. Okay? Number 3, gas emitted can be harmful to health as fine ash particles can cause respiratory problems. Okay? Then, number 4, ash falls are dangerous to aircraft and structures. Yung mga panghimpawid natin. Okay? Next. Okay, earthquakes. So tapos tayo sa volcanism, let's now proceed to earthquakes. Next. Okay, earthquake. This word came from the Greek word seismos, which means earthquake. So it is the vibration of earth due to the rapid release of energy. Okay? So here sa earthquake, we have 2 points. Okay? So una, yung focus or yung hypocenter, this is where the first motion of an earthquake originates. So dun mismo nanggagaling yung sa focus, dun mismo nanggagaling yung earthquake, okay? Dun yung pinagmulan niya, kung saan mismo nagkaroon ng paggalaw, okay? Next, epicenter. This is the point on the surface directly above the focus. So dun yung zenith niya, okay? Yung pinaka tuktok niya, okay? Yung ano niya, yung directly above kung nasaan yung focus natin. Okay? Next. Next, types of earthquakes. Okay? So, we have here the following types of earthquakes based naman sa depth ng focus, kung gaano kalalim yung focus. Okay, so we have 3 na. Shallow focus earthquake. So this has its focus depth ranging from 0 to 50 kilometers below the ground. So mula dun sa surface, so kapag ang focus is 0 to 50 kilometers from the Earth's from the surface, so that is a shallow focus earthquake. And then kapag intermediate earthquake naman, 50 to 250 kilometers below the ground. And then mag-deep focus earthquake, 250 to 700 kilometers below the ground. So mas malalim. Next. Okay. Other types of earthquake naman based on their nature. Okay. So we have here 4. Okay. So una, tectonic. This type of earthquake occurs when the Earth's crust breaks due to geological forces on rocks and the joining plates that cause physical and chemical changes. So it is the most prevalent type of earthquake. So ito naman yung natural, isa sa natural type ng earthquake dahil nga yung ilalim ng earth ay hindi naman pure solid. So meron tayong layer sa earth na kung saan lumulutang yung ano natin. Okay? Lumulutang yung crust natin. Okay? So that's yung asthenosphere nga. So dahil doon nagkakaroon ng paggalaw. Hindi dahil sa paggalaw, nagkakaroon din of course ng earthquakes na nararamdaman dito sa atin. Okay? So that's tectonic earthquakes. The next, volcanic earthquake. So this type of earthquake results from tectonic forces which occur in conjunction with volcanism. So, of course, kung nagkaroon ng flow ng volcanic materials or nagkaroon ng eruption, of course, may release of energy. And with the release of energy, there's an earthquake. So, that's volcanic earthquake. Okay? Next, collapse. This type of earthquake occurs near underground mines. So, it is sometimes referred to as mine bursts. It is instigated by the pressure generated within the rocks and leads to collapse of the roof of the mine, instigating more tremors. So basically, collapse happens sa mga mining areas. Okay? Next, explosion. This type of earthquake is caused by nuclear explosions. Okay? From the word itself, explosion. Next. Okay, elastic rebound theory. Okay, so this theory discusses the processes whereby rocks bend, store, and sudden release energy. It was proposed by Harry Fielding Reid. Okay, so we have here yung theory niya. So una, of course, meron tayong existing na fault zone, okay? Yung fault, yung break sa Earth's crust, okay? And then once na nagkaroon ng stress doon sa fault na yon dahil nga break siya, okay? Broken part siya. So may chance na magkaroon ng stress. And then kapag nagkaroon ng sudden release or na tulad dito, tingnan niyo dito sa third picture dito, nagkaroon ng parang pagkiskis sa dalawang part ng fault, sa dalawang part or dalawang side, okay? So with that, nagkakaroon ng sudden release of energy dahil nga dun sa paggalaw na yon. So biglaan. 'Di ba parang halimbawa sa goma, 'di ba? Pag nagkakaroon na overstress and then kapag bigla mong naputol, 'di ba? Ganun siya. Parang ganun yung concept nito. Okay? Next. Okay, next, seismic waves. So seismic waves, so are are elastic shock waves caused by the sudden breaking of rock or an release of energy. So ito yung nag-travel through the interior of the Earth. So interior, okay, sa loob siya ng Earth nagka-travel. So these waves are of a higher frequency than surface waves. So pag higher frequency, ibig sabihin frequency mas madalas yung wave. Ibig sabihin mas maliliit yung wavelength niya. Okay? Proceed tayo sa types ng body waves. Okay. A. Primary wave. Okay. So this type of body wave is the fastest seismic wave, reaching a speed of 8 kilometers per second through the mantle. Both in speeds and fluids, of that, by pushing rocks in the bush, they are traveling. Okay, so now let's proceed to seismic waves. Okay, so sabi dito, these are elastic shock waves caused by the sudden breaking of rock or an explosion. So kapag nagkaroon ng sudden release of energy, so yung it will be in the form of waves or itong seismic waves. Okay, so we have types of seismic waves. Okay. So, unahin natin body waves. So, this seismic wave travel through the interior of the Earth. Take note of that. Interior of the Earth. Sabihin sa loob ng Earth natin. Okay? So, these waves are of higher frequency than surface waves. So, pag higher frequency, mas maliliit yung wavelength. Sabihin, mas parang kung titignan niyo siya sa isang seismogram, okay? Maliliit, parang sobrang ang lilinya niya, sobrang yung slope niya mas makikitid siya, okay? So ganun yung body waves, okay? So we have subtypes. So una, primary wave. So primary wave is a type of body wave which is the fastest seismic wave, okay? Reaching a speed of 8 kilometers per second through the mantle. And it can travel both in solids and fluids by pushing rocks in the direction they are traveling. So, pinupush niya yung rocks kung saan siya heading. Okay? So, P waves make use of compressional force, hence it is also called compressional wave and pressure. Okay? So, mamaya natin kung ano yung itsura ng P wave and itong S wave. Okay? So, next, secondary wave or S wave. So, this type of body wave can only travel through solids. So, kanina, yung P wave, it can travel sa solids and fluids. Pero yung second wave, solid lang siya. Hindi siya nakaka-travel sa mga fluid. Okay? So, it is more destructive than P waves since it has a greater amplitude compared to P wave. So, it moves rocks in a side-to-side motion or a perpendicular motion. So, it is called a shear wave and shake wave. So, kung titignan natin sa isang seismogram, okay, ang unang lalabas ay P wave. Medyo mas mahina siya. And then, next, sa kabilang darating si S wave. Okay? Tapos, mas malaki yung ano niya. Mas malaki yung amplitude niya. Sabihin yung height. Okay? Yung height nung mula dun sa gitna hanggang dun sa pinaka-peak ng graph or nung curve. Yon. So, ganun siya. Next. Okay, yan. Kung makikita natin dito, yan, sa S-wave, sideways yung movement niya. And then sa P-wave, kung titirin nyo, straight lang siya, pero pinupush niya yung kung ano man yung nasa harapan niya. Okay? So, ganun yung pagkakaiba nila. Next. Next, long surface o L waves, okay? These seismic waves travel only through the crust, okay? So kung kanina, yung body waves, sa interior siya ng Earth nagta-travel, pero dito lang sa crust, okay? Ito lang yung nararamdaman natin dito sa crust kung nasaan tayo, okay? So they have a lower frequency than body waves and in turn are easily distinguished on a seismogram. So they are responsible for damages from quakes. So sila yung nararamdaman natin. We have two also. So we have love wave and this is a type of wave whose mathematical model was developed by Augustus Edward U. Love, which is sa kanya pinangalan to, and it is the fastest surface wave and it produces entirely horizontal motion. Okay, it has the largest amplitude among all seismic waves, hence it is a most destructive type of seismic wave. Then next, Rayleigh wave. It is named after John William Strutt, Lord Rayleigh, who mathematically predicted the existence of this kind of wave in 1885. It shakes the ground up and down. So si love wave, horizontal motion, but si Rayleigh wave, up and down. So mas destructive si love wave. Okay? Mas destructive si love. Bakit kaya? Okay? Next. So we have here the diagram. Ito yung itsura ng ano natin, diagram ng Rayleigh wave. So kung makikita nyo sa una, Rayleigh up and down. Okay? Ito sa love wave, sideways, pero horizontal lang siya. So that's love wave and radio wave. Next. Okay. Let's now tackle the factors that affect seismic wave speed. So we have two, the density of the medium, and then two, elastic properties of the medium. Okay? Next, ito naman yung mga ginagamit natin na ito yung mga terms na ginagamit natin at mga isa naman sa ginagamit natin sa pag-detect ng ng seismic waves at sa pag-aaral ng seismic waves. Okay? So una, seismograph. Okay? This is an instrument used to record the intensity, direction, and duration of earthquakes. So ito yung ginagamit natin na pan-detect, okay, ng earthquakes at yung mga yung properties ng earthquake. So ano ang properties niya? May have their intensity, direction, and duration of earthquakes. Okay? Next, seismoscope. This is an instrument used to detect the presence of earthquakes. Sa seismogram, yes, nade-detect rin siya, nag-detect rin siya ng earthquakes kasi syempre, nagre-receive siya. Di ba? Nagre-receive siya ng seismic waves para ma-record. Pero dito sa seismoscope, dito naman yung ginagamit natin to detect the presence of earthquakes. So, ito yung nakakaramdam kung ng mismong earthquake, ng mismong seismic waves. Okay? So, that is seismoscope. So, don't be confused with seismograph and seismoscope. Okay? Next, seismometer. So, this is the internal part of a seismograph, which may be a pendulum or a mass mounted on a spring. So, seismometer nasa loob ng seismograph. Okay? Next, seismogram. This is the record made by the seismograph. Okay? So, don't be confused with seismogram and seismograph. Okay? Seismogram, yun na yung record niya. Okay? Yun na yung plotted na record na nakuha ni seismograph. Okay, ito. Next. Okay. Ito, may sample tayo ditong seismogram. Pero this is not actually a seismogram. Ano na lang siya, parang model na lang siya. Okay? So, una, you have your background noise. Dahil palagi naman may paggalaw. Okay? But dito sa bandang number 2 dito, bilang nagkaroon ng sudden change sa waves, di ba parang sa una maliliit lang, bilang nagkaroon ng sudden na pag-iiba, okay? Yun yung time na dumating si P-wave. Okay? So dahil nga siya yung unang dumarating, automatic yun, kapag nagkaroon ng paggalaw at ng something na na change sa waves, automatic si P-wave agad yun dahil siya naman yung unang dumarating. And then after nun, consequently, darating na si S-wave, okay? And then, darating na sa S-wave. And then, yung next ng mga sumusunod na nare-detect, yun na sila surface waves. Yung mas malalakas na sila. Okay? So, dito sa number 5, nakalagay dito yung S minus P time interval. Okay? So, mahalaga yan dahil ginagamit natin yan sa pagko-compute natin. Okay? So that's a time difference between the arrival of P wave and S wave. Okay? So para makuha yan, just minus lang natin. Subtract lang. S the time arrival of S wave minus the time arrival of P wave. X. Mamaya madadaanan pala natin yun. Okay. Men in seismology. Okay? So, ito yung mga tao na may nagkaroon ng contribution sa seismology. So, una, Sir Robert Mallet. He coined the terms seismology and epicenter. Next, Filippo Secchi. Okay? He invented the first true seismograph in 1875. Next, John, I guess this is Mill. Ganun. Let me search natin. How is it pronounced? Okay, so kung anong pronunciation sa kanya, sa pangalan niya. So he's credited for the 1880 invention of a sensitive horizontal pendulum seismograph. Okay, next, si Zhang Heng. He invented the first seismoscope. Yung ginagamit natin sa pag-detect. Okay, next, James David Forbes. He built the first seismometer. Okay. Okay, dumako naman tayo sa interior ulit ng Earth, okay? Na kung saan related si seismic waves. Okay? Una, shadow zone. So this is an area of the Earth's surface where seismographs cannot detect an earthquake after the waves have passed through the Earth. Okay? P waves are refracted by the liquid outer core and are not detected between 104 degrees and 140 degrees. So itong part na to mula sa pinagmulan, so 104, between 104 and 140, hindi na-detect or walang presence ni P wave. So yung area na yun, yung region na yun, yung tinatawag nating shadow zone ni P wave or P wave shadow zone. Sa S wave naman, S waves cannot pass through the liquid outer core dahil nga hindi na siya makatravel sa fluids and are not detected beyond 104 degrees. So mula 104 degrees, hindi na siya na-detect. So pagka-pass through the S wave sa liquid, nawala na siya dahil hindi nga siya makakatravel sa liquid outer core. Okay? Next, Benno Gutenberg. So he is a German seismologist who concluded that the shadow zone exists because Earth contained a core composed of a different material from that of mantle, causing the bending of the P waves. Okay, so that's the Gutenberg discontinuity. Okay, next, seismic reflection. This is the process of seismic waves bouncing from a certain layer. So reflection, di ba? Salamin, parang salamin, di ba? So nagba-bounce. Okay? From a surface, okay? Or an object, nagba-bounce back siya. Okay? Or nagba-bounce back sa other angle, okay? Next, seismic refraction. This is the process of seismic waves bending from a certain layer. So, sabi ka natin kanina, sa shadow zone, nagkakaroon ng bending, okay? Sa P waves. Kapag nagka-pass through siya yung P wave, kapag nagka-pass through siya sa liquid outer core, di ba? Nagkakaroon siya ng refraction, okay? So, yun yung nangyayari sa kanya, nagkakaroon ng bending. Next. Okay. So we have here yung itsura niya. Ito, sample diagram ng kung paano ba na-distribute yung P waves at S waves. Okay? So from the epicenter, so kung makikita nyo, yung black dyan is yung S waves, and then yung yellow yung P waves. So kung makikita nyo, so simulan natin sa S waves, di ba? Pag tumama dito siya sa liquid outer core, di ba? Nawawala na lang siya. Okay? Pero yung P waves, nakaka-travel naman siya sa liquid outer core, but nagkakaroon tayo ng refraction. Okay? Eh, mula doon sa nakaka-travel yung P waves. And then, dito naman sa banda makikita natin dito, yung P wave shadow zone, kung saan dito nakaka-detect ng P waves. And then, mula rin dyan, including din yung P waves sa S wave shadow zone. Kasama rin siya. Hindi rin dyan na-detect yung S waves hanggang dito. Yan, 104 degrees. So, iba-iba siya. Iba-iba sa mga textbooks. Iba, 103, 104, 105. But, almost the same lang naman. Okay, next. Okay. Seismograph station. Okay, so dito yung mga stations sa kung saan dito tayo nagkakaroon ng pag-aaral or dito yung nagre-receive, okay? Kapag sila yung detect ng presence ng earthquakes dito sa stations na ito, okay? Next, travel time. This is the time required for a wave train to travel from its source to a point of observation. So, a travel time from the source to a point of observation or itong ilan nating stations, seismograph stations, that is a travel time. Yun yung kinakompute natin. Okay? So, mamaya ano natin yan? Papakita natin yan. Okay? Next, triangulation method. This is a method of determining the epicenter of an earthquake that involves seismic records from at least 3 different seismograph stations. Okay? So, ang ginagawa natin dito, dinedetect natin yung travel time from a source to a seismic station. Okay? Or seismograph station or seismic station. Okay? So, we need at least 3 para makita natin kung saan nag-overlap yung detection nila. Okay? So, kung saan yung overlap, I mean not overlapping, I mean intersection. Okay, that's the word, intersection. Okay? Kung saan nag-i-intersect yung kung saan man yung na-detect nila. Okay? So, at least 3, so with that, ma-detect nila kung nasaan yung epicenter natin. Next. Okay. Okay na. Ito na yung formula na gagamitin natin sa pag-calculate ng distance from the epicenter to each seismograph na kung saan ay nasa seismograph station. Okay? So, we have here D is equal to our distance. Okay? Ito yung D represents the distance from the epicenter from the seismograph. And then, time difference over 8 seconds times 100. So, time difference, nakakompute siya using S minus P. Sabi ko kanina, ma-minus nyo lang yung time ng S waves, na pagdating ng S waves minus pagdating ng P waves. Okay? For example, dumating si P waves na Kunyari, dumating si P wave ng 12:04 and then si S wave dumating ng 12:05. Kunyari ganun. So, ang first niya is 1 minute. Parang ganun siya, minus lang natin. Okay? So, ito yung gagamitin natin formula sa pag-compute ng distance from the epicenter to seismograph. Take out of that formula. Next. Okay. Describe an earthquake. Okay? So, meron tayong dalawang paraan kung paano natin de-describe yung isang earthquake. Paano siya sinusukat. Okay? So una, magnitude. This is the total amount of energy